Okay, we use logarithmic differentiation for two types of questions. When we have product of many terms in division, or in if you have powers, see exercise 5.5, the second question. Okay, if we have functions of this type, it's going to be very difficult. Look at the second question of exercise 5.5. So you have two terms in the numerator, and in the denominator, product rule for three terms you have to use, and you have quotient rule also to be used, and the power rule, root is power half. Okay. So it becomes easier using logarithmic differentiation. So in such questions, that is having many terms in product, division and powers, it is better to use logarithmic differentiation. But we have direct method also. We can, without logarithm also we can do, but logarithm makes it easier. Then second type of question is when we have base and the power both variables. Listen to me carefully. This formula of differentiation, n into x power n minus 1, can be used when the base is a variable, the power is a constant. So we can use this for such questions like sin x whole power 3. Okay, so base is a variable, power is a constant. Now the next formula, d by dx of a power x, which is a power x into log a, or d by dx of e power x, exponential functions, which is e power x log e. Log e is 1, that's why we don't write this. Okay, here in these two functions, base is a constant, power is a variable. Base is a constant here. Here also it is a constant. E is a constant. It has a value approximately 2.7. So we use these formulae when base is a constant and power is a variable, like 3 power sin x. The first one is, I said, sin cube x. They are two different functions. Here base is a variable, power is a constant. Here base is a constant, power is a variable. To differentiate this function, we have to use this formula, not this. Similarly, to differentiate this, we have to use this, not this. Okay, now the third one is, if you have, for example, x power x function, say, where both are variables, base is a variable, power is also a variable, we can neither use this nor this to differentiate such functions. So we don't have direct differentiation formulae when both are variables. So we need to use logarithmic differentiation. Okay, so when both base and powers are variables, we need to use logarithmic differentiation. We cannot differentiate directly. So we will do one question where we have product of many terms. Like the second question, you can just go through the first, second and fifth question of your textbook. No need to practice, just go through the answer, enough. I will do one question. Y is given as a root of 1 minus x square, 2x minus 3 whole power half, divided by x square plus 2 whole power 2 by 3. You have to find dy by dx. This is an important exercise. Definitely you will get one question, either for 4 or 6 marks from this exercise. Okay. Now here we have product here, quotient here, and power for each and every term. So it becomes too long if you do directly. So it is better to use logarithmic differentiation. So log y is equal to log of this whole thing, So it becomes log of 1 minus x square whole power half. Product will become into. Product will become plus if you separate the log. It becomes log of 2x minus 3 whole power half. And division will become minus x square plus 2 whole power 2 by 3, which is equal to, I have used that log of p into q as log p plus log q, and log p by q is log p minus log q. Okay, for product, addition; for division, subtraction. Now I am going to use power rule. We have another logarithmic rule. Log of p power n becomes n log p. So these are logarithmic formulae. So using that, it becomes half log 1 minus. Because of this log, I can bring this power here. So we can avoid that power rule differentiation. Half log 2x minus 3 and 2 by 3 log x square plus 2. Now we are going to differentiate. When you differentiate, log has to be differentiated first, then y with respect to x. Differential of log y is 1 by y into dy by dx equal to half into, same chain rule, log first and then this bracket. Differential of log is 1 by 1 minus x square into differential of 1 minus x square is minus 2x. Half is a constant, take it out. Log has to be differentiated, then the bracket, into differential of 2x is 2 and differential of 3 is 0, minus 2 by 3 times differential of log into differential of x square is 2x and differential of 2 is 0. I can cancel these 2's. Now I have to write the answer for dy by dx. So take y to the other side and substitute for y. My y is this, such a big function, the given function, times the first term is minus x over 1 minus x square, the second term is minus 1 over 2x minus 3, and this function is minus 4x over 3 times x square plus 2. We could have taken the minus sign out or leave it in this form. This is the answer. If you want, you can take the minus sign out. So when we have product of so many functions, it is better to use logarithmic differentiation, which makes the differentiation easier to do. Now we will do the other questions, your textbook question. So I want you to practice question 6, 7, 11th one is very, very important. We will do that 11th one now. Question 11, page number 178. So let us take the expression as y whole power 1 by x. Because of this plus sign, we cannot take log in this step. Don't write log y is equal to log of this plus log of this. We don't have logarithmic rule for addition and subtraction. Okay, because of this plus sign, we cannot take log in this step. So then we need logarithmic differentiation because the base is a variable, power is a variable. Here also base is a variable, power is a variable. Now we have x terms everywhere. So we need logarithmic differentiation, but we cannot take log because of this plus sign. So to avoid that, we will take the terms separately. So we will take the first term as a u, the second term as v. So we will differentiate them using logarithmic differentiation, and we'll put them together using plus in between. So I'm taking log on both sides. Now it becomes x into log of x cos x. That log of p power n into log p we can write. That method I have used, that formula. Now this is my u and the whole thing is my v. Let us differentiate. Chain rule, log has to be differentiated, then u. So 1 by u into du by dx equal to product rule, u dashed into v plus u v dash. Do it carefully. You have to use chain rule as well as product rule here. X into u have. So differential of log first, which is 1 by x cos x, into then differential of x cos x using product rule. So you will have this as u and this as v. This is u, this is v. So 1 into u dash into v plus u v dash. Differential of cos x is minus sin x, so use brackets because of that minus sign. I can cancel these two x. Now I am writing the answer for du by dx, taking u to the other side and substituting for u. U is x cos x whole raised to x into this answer, log of x cos x, and I can open the brackets, no? Cos by cos is, this is common to both the terms. Cos by cos is 1 minus, and this becomes x tan x. This is our first term's differentiation. Now we will take v. Here definitely we need logarithmic differentiation as the base and the power both are variables. So I am taking log. So log of x into sin x whole power 1 by x, that power comes here. Now this is u and this is v. Let us differentiate. Differential of log into differential of v with respect to x equal to, differentiate the other side, u dash, differential of 1 by x is minus 1 by x squared. Memorize like a formula. Otherwise it is easy, x power minus 1. 1 by x is x power minus 1. So to differentiate, base is a variable, power is a constant, so you can use n into x power n minus 1 formula. Okay, next one. U dash into v plus u v dashed. You have to apply chain rule as well as product rule. Differentiate log first into, you have to differentiate this x sin x using product rule. So x is our u, sin x is v. 1 into sin x, u dash v plus u v dash, differential of sin x is cos x. Now take v to the other side and substitute for v. v is x sin x power 1 by x into this term. So log of x sin x, there is a minus sign, over x square, and here also we will have x square. This x square I wrote. Now I will divide by sin x and write. Sin by sin becomes 1 plus, I cannot cancel x, I wrote x square. So x cos x by sin x will become x cot x. This is the answer for the second term. So our equation was y equals u plus v. So dy by dx will be du by dx plus dv by dx. So you have to add the answers and write. So the final answer is the first answer, which is x cos x whole power x into log of x cos x. This is our second answer. I am writing the first answer, plus 1 minus x tan x. This is du by dx, plus I have to write the second answer. Second answer is x sin x whole power 1 by x into, I can write it as whole x square, so minus log of x sin x plus 1 plus x cot x. This is the final answer. So I told you to practice 6th and 7th questions. Other questions, at least go through the answer. Everything is important, at least go through the answers of the other questions. Okay, now 12th. Okay, let us do the 12th question. 13th, 14th are different type. So let us first do the 12th one. I'm changing the board. X raised to y plus y raised to x equals 1. Now look at the first term. Base is a variable, power is a variable. We need logarithmic differentiation because we cannot differentiate directly. Here also base and powers are variables, we need logarithmic differentiation. But there is a plus sign in between. We don't have logarithmic rule for plus sign. So we will take the first term as u, second term as v. We will use logarithmic differentiation. So log of x power y, that power comes here. Now let us differentiate. Here we will be using product rule. Differential of log is 1 by u. Differential of u with respect to x. U dashed into v plus u v dashed. Now take u to the other side and substitute for u. So you get dy by dx into log x, y by x. This is like implicit function. This is an implicit function. Okay, this is our first term. Now we will take v, take log on both sides. Why are we using logarithmic differentiation? Because both are variables. So it becomes log y power x. That power can be written here, the logarithmic rule I have used. Now let us differentiate. Differential of log is 1 by v into differential of v with respect to x equal to u and v. U dash into v plus u v dash. To differentiate this, log has to be differentiated first, then y. Differential of log is 1 by y into differential of y with respect to x. Now we have to write the answer for dv by dx. Take v to the other side and substitute for v. This is our second answer. Now I am writing the given equation. X raised to y plus y raised to x is equal to 1. Let us differentiate. Differential of this is our first answer. I am copying. Plus. Now differential of this is our second answer. I am copying that also. Equal to differential of 1 is 0. It's not 1, the other side becomes, you have to differentiate 1, which is 0. This is an implicit equation, I said, so we have to collect dy by dx terms. So x power y log x dy by dx plus x, I'm just opening the brackets, I'm distributing it, y power x into x by y dy by dx equal to 0. Now I can simplify this and this, they are like terms, no? Here the power is y, here the power is 1. So y minus 1, the power becomes x power y minus 1 into y power x log y. Here also y power x by y we have, so it becomes y power x minus 1 into x dy by dx equal to 0. Now let us collect dy by dx terms. X power y log x, we have dy by dx here as well as here. So from that last term we get y power x minus 1 into x equal to, take these two terms, they don't have dy by dx, to the other side. So both will become negative. I have taken the negative sign common. Now let us write the answer for dy by dx. So it becomes, there is a minus sign, x power y minus 1 into y power x log y divided by this term, y power x minus 1 x plus x power y log x. This is the answer. Okay, 13, 14, 15, these three questions are different type because look at the 13th question. In all the other questions, that is 4th onwards, 4th, 6th, 7th, don't see the 5th one, 4, 6, 7, 8, 9, 10, 11. You have plus sign or you may have minus sign also in between, like the 4th question, you have a minus sign in between. So we couldn't use log in that first step itself. 12th question also, you have to use u and v separately, and we took logarithmic differentiation and we differentiated. Whereas, look at the 13th question, y power x is equal to x power y. There is no plus or minus sign in between the functions. There is equal to sign. We don't have any problem with equal to sign. Only when there is plus or minus sign, you cannot use log in that equation, in that step. So here we can. Similarly, look at the 14th, a cos x whole power y, this is one function, cos y whole power x, again we don't have plus sign in between, it is only equal to. Same thing with 15th also. This is only product. We have logarithmic rule for product. Okay, so we can use directly, we can use log for these three questions because we don't have plus or minus sign between the functions. Okay, so we don't need that u and v for these three questions. So we will do one of these questions. We'll do the 14th one. You practice the 13th one. Practice, do by yourself. Cos x whole power y is cos y whole power x. Since there is no plus or minus sign between the functions, I can use log. So log of cos x power y equal to log of cos y power x. So I am using that log p power n logarithmic rule. X log of cos y. Now I am going to differentiate. So we have to use product rule. This is u, the whole thing is v. Similarly, this is u and the whole thing is v. Let us differentiate u dashed with respect to x into v plus u v dashed. You have to use chain rule. Log has to be differentiated first, then cos. Differential of log is 1 by cos x into differential of cos x is minus sin x. Because of the minus sign, use brackets, equal to. Now I have to differentiate the other side. U dashed. Differential of x is 1 into v plus u v dash. Differential of log is 1 by cos y and differential of cos y is minus sin y into differential of y with respect to x. Don't forget this term, dy by dx. Here it was x. Differential of x with respect to x is 1. So that's why we didn't write anything. Okay, now we have to collect dy by dx terms. So dy by dx into log of cos x from this term. Now let us bring this term to this side. So minus will become plus. X sin by cos is tan y and dy by dx has been taken out, equal to log of cos y. I have written this term, and let us take this term to the other side. Minus will become plus y sin x by cos x is tan x. Now we can write the answer for dy by dx. So dy by dx is y log of cos y plus y tan x divided by log of cos x into plus x tan y. This is the answer. Now the 15th question can be done without logarithmic differentiation also, because left hand side product rule, right hand side we know how to differentiate e function, but logarithmic differentiation will be a little better, easier to do. So practice 15th question. Now I have given one extra question. You have written it in your textbook. We will do that. If x power m into y power n equal to, so many times this question had been asked in the board exam. Prove that dy by dx is equal to y by x. Actually here also we don't need logarithmic differentiation, but like the 15th question, but logarithmic differentiation makes it easier. Okay, the number of steps will be reduced. So I am taking log. Taking log on both sides, we get log of x power n. Product will become plus now if you separate the log functions, equal to log of x plus y. For plus we cannot separate, so write it like this only, power m plus n. Now power rule, that logarithmic rule, log of p power n is n into log p. So this rule I am applying, m log x, n log y, here m plus n, log of x plus y. We cannot separate this log of x plus y, we don't have a rule, so keep it like that only. Now I am going to differentiate, differentiating with respect to x. M is a constant, differential of log x is 1 by x, plus n is a constant, differential of log is 1 by y, into differential of y with respect to x. Here differential of x with respect to x is 1. M plus n is a constant, take it out. Differential of log is 1 by x plus y, into the bracket has to be differentiated. Differential of x is 1 plus differential of y with respect to x. Now let me open the brackets here. So m plus n by x plus y into 1 plus, I am distributing, m plus n by x plus y into dy by dx. I have opened the brackets. I have to find dy by dx. I am collecting dy by dx terms on one side. We have n by y here. Bring this to this side. It becomes negative. Now take this term to the other side. I am going to take LCM on both sides. Here the LCM is y into x plus y. So it becomes n into this, nx plus ny minus of my plus ny. There is a minus sign in between. This is common to both, so use brackets. Here the LCM is x into x plus y. So you get mx plus nx. Again minus sign is there, use brackets. This x plus y and x plus y will get cancelled. Now in the numerator, ny minus ny, mx minus mx are getting cancelled. I am writing the remaining terms, nx minus my by y, nx minus my by x. Now look at the numerators. Numerators are common, we can cancel them. Now we get the answer, dy by dx as y by x. This is the answer to be proved. Okay, this is a board question. Differentiate with respect to x cos of x power x. Definitely we need logarithmic differentiation because base and the powers are variable. Okay, if I take log, I cannot bring this power here. If it is cos x whole power x, and if I take log, then this can be brought here. This is under bracket of cos. I cannot separate this. Understood? So I cannot take logarithm here. It's an important question. It is a board question. So y is equal to, I will take, so we don't know how to differentiate x power x. So let us take that alone as u. Don't take along with that cos, because you cannot use the logarithmic rule. Now I am using logarithmic differentiation. I am taking log on both sides. I am differentiating. Here this is u and this is v. U dash into v plus u v dashed. This becomes 1, not 0. Du by dx is 1 plus log x into u. So I can substitute for u. Okay, now let us differentiate the given function. So dy by dx will be, differentiate, chain rule has to be applied. Differentiate cos first, which is minus sine of the same inner function, into, now I have to write the differential of this, which I have calculated separately. Differential of x power x is this. So x power x into 1 plus log x. This is how we do this question. This is the answer. Okay, next. We'll do one more question. No, I have to do a few more. Okay, next question. This is also a board question. If x raised to y equals e power x minus y, prove that dy by dx is equal to log x by 1 plus log x the whole square. This is the given equation. This side doesn't have any problem. We can do direct differentiation, but this side has a problem. Both are variables. We need logarithmic differentiation. So I am taking log on both sides. So it becomes y into log x, logarithmic rule. This is x minus, keep the base and the power has to be brought here. Power is x minus y log e. Log e is 1. Log e to the base e is 1. Now I am going to differentiate. Here I have to use product rule, u and v. U dashed, with respect to x we are differentiating, into v plus u v dashed. Differential of x with respect to x is 1, equal to, the other side has to be differentiated. Differential of x with respect to x is 1 and differential of y with respect to x. This is an implicit function, so we have to collect dy by dx terms on one side. If you take this to the other side, it becomes plus, so plus 1. 1 minus y by x. 1 is here, take this to the other side. So dy by dx is equal to x minus y by x into 1 plus log x. But look at the answer to be proved. The answer is this. Okay, we can substitute for y. There is no y in our answer. We can substitute for y. So from here, we have to find y. Okay, this is one method, or I'll show you the other method also. I'm finding y from this equation. So y times log x plus 1 equal to x. So y will be x by 1 plus log x. Now substitute this here. So x minus x by 1 plus log x. I am substituting for y. Now take LCM and simplify. So you get x plus x log x minus x by 1 plus log x, and the LCM is also 1 plus log x. That LCM I have written in the denominator. Are we getting the answer now? What is the answer to be proved? Yeah, we get. So this is equal to x log x, x into 1 plus log x the whole square. And this is the answer. This is one method. The other method is, okay, listen to me. No need to do these steps. Okay, after this we are doing this. No, we have written y as a function of x. That is, we made it an explicit function. This is an implicit equation, but by collecting y terms on one side and finding y as a function of x, we made it an explicit function. So we can continue here to differentiate. No, dy by dx directly you will get. So that is another method which is easier. So dy by dx, I am differentiating this. So I have to use quotient rule. V square here. And here we get u dash into v minus, quotient rule has minus sign, u v dash, differential of 1 is 0, differential of log x is 1 by x, which is equal to log x. Directly we get the answer, the whole square. Okay, you can do it like this also instead of doing these steps. So from here make it an explicit equation, then differentiate, directly you get the answer, no substitution required. Then next question. I am changing the board. This is also a board question. Differentiate x power x. 3 levels are there. So you should know how to use that logarithmic p power n rule. So let me take y as x power x. Of course we need logarithmic differentiation. So log y is equal to log x power x. When you use this logarithmic rule, you have to keep the base alone when the brackets are not given. The rest of it should be brought here. So keep the base alone. The rest of it should be brought here. X power x log x it becomes. Whereas if it is written as x power x whole power x, we will do that question also. Okay. So keep the base alone and bring the other rest of it here. Again we have a problem because of this x power x again. So I am taking log again. So it becomes log of x power x plus log of log x. It's a board question. So this product becomes addition if I separate the logs. There is already log is there and we are also taking log. Now this becomes x log x and this is log of log x. Okay, now there is no power. I can differentiate, chain rule. First this log, then y. Differential of the first log is 1 by log y. Differential of the second log is 1 by y into differential of y with respect to x. Here we will be using product rule. Here next term is chain rule. Okay, u dash into v plus u v dash. Differential of x with respect to x is 1. Here first this log has to be differentiated, then this log, then x. Differential of the first log, then differential of the second log into differential of x with respect to x. This becomes 1. Now we will write the answer for dy by dx. So dy by dx is equal to, I'm taking y and log y to the other side. First term is log x, second term is 1, third term is 1 by x log x. Okay, let us substitute for y and log y. So y is x power x power x. Here it is. And now I have to substitute for log y. Log y is this, x power x log x. Into log x plus 1 by x log x. This is the answer. Now in case if the function is this, say power x, this becomes x into x squared. Okay, we can multiply, no? Even if you take log here, see, in case without multiplication, if you take log, you can keep the base. Here base has a bracket, so you cannot separate the bracket. You cannot. So it becomes x log x power x. Again, to do this, you need logarithmic differentiation. Separately, you have to use u. Okay, better is taking this as x square, because we can multiply the exponents, no? X square it becomes. Now I am taking log on both sides, and I told you we have to keep only the base here. There is no bracket, so I have to bring, leaving the base, I have to bring everything down when there is no bracket. Now x square has no problem, it's a constant, no? So I can differentiate now. This is u and this is v. Differential of log is 1 by y into dy by dx, u dash into v plus u v dashed. Now take y to the other side and substitute for y, and 2x log x plus x. This is the answer. Okay, now we will move on to the parametric form. Parameter is a third variable will be involved. So x and y will be expressed in terms of a third variable, which is called the parameter. It may be t, theta, anything. Okay, so the first 5 questions are very, very simple. You have to practice the 6th question. 10th is very important, and 7th you have to learn the simplification. Okay, now we will do the 8th one, exercise 5.6. X is a times cos t plus log tan t by 2. Let us differentiate. A is a constant, take it out. Differential of cos with respect to t is minus sin t. Here chain rule. Log first, then tan, then t by 2. Differential of log. Differential of tan, sec square t by 2 into differential of t by 2 is half. Sin t. I'm changing everything in terms of sin and cos. 1 by tan is cos t by 2. 1 by tan is cot. Cot is cos by sin. And sec square is 1 by cos square into half. One cos function gets cancelled. And here we have 2 sin t by 2 cos t by 2. We can use sine 2 theta formula because 2 sine theta cos theta is sine 2 theta. That is 2 times t by 2, which becomes t. We can simplify further. Let us take LCM. That's why I am doing this question. Don't leave it in this form. So you have to simplify this. Minus sine square t plus 1. So 1 minus sine square is cos square. See, 1 minus sine square you have, divided by sine t. Keep it in terms of sine and cos only. Simplification will be easier. This is dx by dt. Now y is given in the question. It's a very simple function. Let us find dy by dt. A is a constant, take it out. Differential of sine t is cos t. We have to find dy by dx. So we have to divide. Be careful in parametric equations. I told you which has to be in the numerator and which comes in the denominator. Decide and do it. So dy in the numerator. A gets cancelled, cos gets cancelled. It becomes sin t over cos t, which is tan t. You have to find only the first derivative here. I told you to practice the 10th question. Okay? 10th, 5th and 10th. The first 4 questions just go through the answer. 9th is also go through the answer. 6th you may go wrong in writing dy by dx. That 1 you will forget to differentiate, which becomes 0. So you may practice that also. Many will do that mistake, because here it becomes 1 minus cos theta, no, in dx by dt. Similarly, you will write 1 minus cos sin theta for that. Okay, 11th question. Here in this textbook question, it is given without eliminating the parameter. So dx by dt, dy by dt and divide. That's how you have to do. In case, if it is not mentioned without eliminating the parameter, is not mentioned, say, then eliminating the parameter and doing is easier. So this is x, this is y. So we can eliminate t easily by doing x into y. So x into y is under 1 root I can write into cos inverse of t, which becomes, we have to add the exponents, the power becomes pi by 2 formula. This whole thing is a constant, because a is a constant, pi by 2 is a constant, so everything is a constant here. So when you differentiate a constant, the answer becomes 0. Here product rule, u and v, u dash into v plus u v dash, with respect to x we are differentiating, equal to 0 because it is a constant. Therefore dy by dx is minus y by x. So simple it becomes. In case if the question says without eliminating the parameter, then you have to differentiate separately, as we have done it in the notebook. Okay, if it is not mentioned, this is easier, this method. Okay, now we will do few extra questions of this. I am changing the board. This is a board question. X equals e power theta times this, and y equals e power minus theta times. Let us find dx by d theta. We have to use product rule here. Differential of e power theta with respect to theta is e power theta, u dashed. into V plus u v dashed. We have to differentiate this with respect to theta. Differential of theta with respect to theta is 1, and differential of 1 by theta is minus 1 by theta square. I told you to memorize. Differential of 1 by x is minus 1 by x square. Okay, I can take e power theta common. So it becomes 1 plus theta plus 1 by theta minus 1 by theta square. Then y. This is u, that is v, dy by d theta. U dashed is e power minus theta into minus sign. Don't forget this minus sign. Differential of e is the same function into differential of the power gives you minus 1 into v plus u v dash. Differential of theta is 1. Differential of 1 by theta is minus 1 by theta square. So minus and minus will become plus. I can take e power minus theta common. I get this. I could have taken LCM also. Okay, I will do it in the next step. Now I am going to calculate dy by dx. So it is dy by d theta by dx by d theta. So dy in the numerator, I told you be careful. Okay, I will take LCM and write here. LCM is theta square. So it becomes minus theta cube plus theta square and 1. Denominator is dx by d theta e power theta. Again I am taking LCM for this. Theta square is the LCM. So I get theta square, theta cube plus theta minus 1. Now cancel the LCMs. I can simplify this and write this as e power minus 2 theta. These two will get cancelled. The numerator is minus theta cube plus theta square plus theta plus 1 divided by the denominator is theta cube plus theta square plus theta and minus 1. This is the answer. Okay, next question. Other questions are easy only, you will be able to do them. Okay. We will do one more question of this type, parametric. This is a simple question, but x is a cos cube theta, cos cube t, y is a. This is also a board question. We have to find dy by dx. So dx by dt, a is a constant, take it out. Here chain rule, power has to be differentiated first, then the base. So 3 cos square t, keeping the base same. When you do one level, the other level should be kept as it is. Now the base sin cos t, don't see the power now. Only the base cos t has to be differentiated. So minus sin t. dy by dt. A is a constant, differentiate the power, then the base. Now dy by dx, be careful, dy should come in the numerator. For every question I am repeating this, so in spite of that, some of you will do that mistake. So if I repeat something, there are chances of doing that mistake, so be careful. So one sine gets cancelled, one cos gets cancelled. So we get minus sine t by cos t, which is minus sine t. In case if value is given, t value, you will finally substitute that. Okay.